Now the topic is tide. Tide is the rise and the fall of sea water level. It's the rise and the fall of sea water level. Basically, it's the vertical movement of the ocean water. This is the rising part and this is the falling part. This is rising part and this is the falling part. Rising part is known as zone of high tide. It is the zone of high tide and it's the zone of low tide. Okay, it's the vertical movement of the ocean water. It's there will be rising part is known as high tide and falling is known as low tide. Okay, now come to the point of ebb tides and the flood tides. Okay, this is the rising part and this is the falling part. Again, it's the rising part. This is the zone of high tide. It's the zone of low tide. Okay, this is the rising phenomena and it's the falling part. Okay, so there will be several sequential changes of height of the level and alteration of the rise and fall. If the stages where the sea level keeps receding from high tide to low tide keeps receding over the several hours, this is known as ebb tides. Ebb tides. Okay, it's the phases from high tide to low tide. Okay, and again the period of several hours there will be rise in the sea level, low tide to high tide. This is high tide. This phase is known as flood tides. Flood tides. Okay, ebb tides is the falling part, that is the receding part, and it is the increasing or rising part. This is known as ebb tides. Okay, next come to the causes of tides. What are the principal causes behind the tides? Okay, there are two important causes. Those are the responsible for the tide. First one is the gravitational pull of moon and the sun, and second one is the rotation of the earth. Okay, but we are all familiar that the gravitational pull of moon and sun is not equal. Rather, attraction of moon or the gravitational pull of moon on the earth is 2.2 times higher than the sun. Okay, first this is a very important thing, plays a very dominant role in the tides, because due to the rules of gravity, due to the rules of attraction among the celestial body, all the masses attracted to each others. The force is proportional to the masses and inversely proportional to the square distance. This is the basic reason behind the fact that moon attraction or the moon gravitational pulls on the earth's surface is higher than the sun. It is 2.2 times higher than the sun. Okay, now come to the phases of tides. Okay, suppose this is the sun. Suppose this is sun. Suppose this is moon. M for moon, and it's the earth. Okay, it's the earth. North pole and south pole. Earth is moving from west to east, and moon is moving equally in same direction. This is moon orbit and this is the earth orbit. Okay, moon is moving here. Moon is moving from west to east. The moving direction of earth and the moon is the same direction. Basically, due to the gravitational pulls, all are attracted by the gravitational pull. Due to gravitational pull of the moon, the earth hydrosphere, earth ocean surface tend to accumulate in the part that is direct towards the moon. This is the direct part. So earth hydrosphere accumulated on that part. And directly opposite, this is the directly opposite part, and also water accumulated in the directly opposite part of the earth. This zone is known as high tide zone. High tide zone. And this is also the high tide zone. And simultaneously, water in those places, water falls down. This is the low tide zone. This is the low tide zone. This is the basic thing. This is the basic principle of tides. So the what is the tides? Tides is due to the gravitational pull of moon and sun. Gravitational pull of moon, pull or attraction of moon is higher than the sun, and it is related to the earth's rotation. I will explain it later. And due to the gravitational pull of moon, earth hydrosphere or the earth ocean surface tend to accumulate on the path direct to the moon, and exactly opposite. This is exactly opposite to the moon. So those part, exactly direct part and exactly opposite part, is a zone of high tide. There is a rise of seawater level, and simultaneously on those part there is a falling of seawater level. This is the zone of low tides. Okay, here be clear. We are familiar that the tides is due to the gravitational pull of moon. So why in opposite direction? Now the question is, why the opposite direction? Why the ocean is swelling just opposite direction of the moon? What is the basic reason or basic fact behind that? Before going to that fact, two things is very important. This is art surface, and that direction water is swelling due to, this is moon, due to attraction of moon. And why that part earth is swelling? This is the basic question. The other two things is very important. Two principles are very important. That it is clear that the front side or front facing side, this is earth, this is moon, front facing side, the moon, due to direct attraction of the moon or the moon gravitational pull, the water is accumulated and there is a high tide zone. But why in opposite side? There is two basic reasons behind the fact. That the first one is that the apparent gravitational field. Apparent gravitational field. Apparent gravitational field. First one is the, and second one is the earth and moon. Both are moving. Here earth is spinning on its axis, that is North Pole, geographical north and geographical south. Earth is spinning on its axis and moon is moving around the earth. Here the second important point is that earth and moon is a system that orbiting around the common center gravity. So earth and moon both have a common center gravity, and earth and moon, earth is spinning and moon is orbiting to, on the basis of, on the center of, on the, due to attraction of common center gravity. Center gravity. First one is the apparent gravitational field, and second one is the common center gravity. Due to those causes, basically due to this reason, earth hydrosphere, earth ocean surface is swirling in the just opposite direction of the moon. Okay, we can take few simple example. Okay, suppose someone is moving. Okay, suppose someone is moving in the car. Suppose this is a car, someone is moving, okay, with a flag. Okay, the car is moving in that direction due to the forces of engine. The lucid part, the loose part, that is the flag part, moves and that direction. Okay, in Bengali there is a word, there is a phrase is ধ্বজা লয়ে যায় প্রতিকূল বাতে পতাকা ফিরায় মুখ তাহার পশ্চাতে. The flag holder moving that direction, but flag is moving in that direction. Okay, suppose we can take another simple example. If you are riding in a car, suppose this is in car path, you are riding in a car is moving in the right hand direction, but here the passenger feels that they are moving in left hand. So force is there and this is just opposite to that force. This is known as inertia counterbalance. So be clear why two types occurs in just opposite direction of the moon, just the far side. Suppose this is the earth, this is the moon, this is the direct side and this is the far side. Why the tides occurs in the far side? Due to basically for the inertia counterbalance, due to the apparent gravitational field, and due to the earth and moon system orbiting around the common center. We can take a very simple example from that. Suppose you are standing here. Your friend is stretching your hand, pulling you, and you try to maintain a balance to stretching your hand towards your friend, but you try to stand your own position. Your gravity is here, so you have to maintain a balance, and for that purpose someone have to spread his or her hand and stretch in that direction. Then that human being slightly moved on curve on that direction. This is the fact of counterbalance of inertia, and this is the fact of due to centrifugal force, and so on. Okay, okay, suppose y in opposite direction. Suppose this is moon and this is earth. Okay, here two body, earth and moon, both are attracted to each other. There is a gravitational pull. Moon pulled the earth due to gravitational force, and also earth is pulling the moon. And but here the moon's gravitation mg for the moon is higher than the earth gravitational pull. Okay, so due to that the moon gravitational pull mg is higher than the earth gravitational pull, so the hydrosphere is swelling to that direction. Okay, even from that point, and that point, water is swelling, earth, hydrosphere, ocean is swelling, but each and every point of the gravity is not same, because it's inversely proportional to the square distance. So there will be a counter inertia, and there will be a centrifugal force, and that will move in that direction. Here the centrifugal force is higher than in the opposite direction. In the opposite direction of the moon facing, centrifugal force is higher than the moon's gravity. That's why in opposite direction, it is also called as a counterbalance of inertia. This is for that reason the earth hydrosphere is swelling in the opposite direction. Okay, so this is the basic reason why the earth is swelling in the front side and the far side of the moon. Okay, next come to the types of tides. Types of tides are basically two types. First one is the on the basis of position of sun, moon and earth. You can also describe that this basically on the time phase. This is also described in the 27.5 days. Okay, and second one is the on the basis of frequency, or the on the basis of rotation, or on the basis of lunar day or solar day. This division is basically through a month, and this division is basically through a solar day or lunar day. Okay, first one is the based on the position of the sun, moon and earth. There are two types, spring tide and neap tide. So okay, first we have to explain the spring tide and neap tide. Before going to the spring tide and neap tide, we have to clear our idea about the moon's orbit. Okay, suppose this is moon orbit. Suppose it's the earth. It's the earth. Okay, this is the moon. Okay, moon and earth both are moving from west to east. Both direction is same. So moon start journey to this direction and complete its orbit within either 29 days or the 27 days. Why I am saying 29 days or 27 days? Both are true. Why both are true? There are two types of moon's orbit. One is known as synodic month or synodic moment. Another is called as sidereal moment. If we consider the moon orbital time period from the earth perspective, it is 29 days. And if you consider the moon orbital period, return to the same position, again back to the same situation, same position. Suppose we start from journey from here and up or completing its orbit and reach in the same position. If we consider in the reference to the star or the sun, so it is known as a sidereal. So in moon's orbit, in the cases of tides, normally considered within the scale of sidereal orbit. On reference to the sun orbit, it is normally 27 days, 27 and a half days. Okay, this is the moon orbit. It's known as moon sidereal orbit in reference to the star or the sun. Second thing is that the solar day and lunar day. Before going to division, you have to clear this idea. Suppose, earth is revolving on its axis, earth is spinning on its axis in 24 hours. Rather, earth is moving 360 days into the 24 hours. Then better to say earth moves 90 degrees in 6 hours. Okay, we are clear about that. Now, if earth complete its journey from west to east, complete one rotation, it takes 24 hours. And suppose earth start to spin, and after 24 hours, earth will achieve the same location. And moon is also moving and direction is same, west to east. So suppose earth start to spin from that point, and after 24 hours it complete one spine and reach to the same location, and it will take 24 hours. But moon start to moving in that direction after 24 hours. When earth will achieve that location, then moon will move towards east. So there will be gap. Before 24 hours back, moon and earth position was there, and after 24 hours there will be gap. To achieve this distance, moon to achieve this distance, to earth have to spend 15 minutes more than the earth. So lunar day is 50 minutes. It will take 50 minutes to reach the moon. So lunar day is 50 minutes longer than the solar day. Okay, but both are moving west to east, moon and sun. It takes 50 minutes extra to catch up the moon. So the lunar day is 24 hours 50 minutes. So the basic division of types of tides depends on the sidereal movement of the sun. It is 27 and a half days. And another division, that is the day-to-day division, that is basically on the lunar day. So comes to the division of what types of tides. Okay, so first thing is that the spring tide, and second one is the neap tide. What is spring tide? Suppose this is sun, this is moon, and it's the earth. Here Earth is spinning on its axis and moon is moving from west to east. Suppose moon starts journey from that point. That point there is a linear alignment. Sun, moon and earth are in 180-degree alignment. Okay, but moon in the sand middle. Here earth, right hand side there is an earth and left hand side is sun. This is the day is new moon day. In Bengali it is called Amavasya. This 180-degree alignment, there will be strong high tide in the direct facing side of the moon and just opposite side of the moon due to cumulative attraction forces of the moon and sun. And there will be two low tide here and two high tide here and here. This is known as spring tide. This is the day of first new moon day. This is called known as Amavasya in Bengali. After that, moon is moving from west to east. After that, moon will slowly come and after that there will be the alignment of sun, moon and earth. This is sun and this is earth and this is moon. This is the alignment is 90-degree. This 90-degree alignment is known as Neap tide. Okay, 180-degree alignment is known as spring tide. Okay, so there will be high tide in 90-degree alignment. There will be high tide in that position and that position, and there will be low tide. Okay, after that moon is moving and is to that direction. This is also the 180-degree alignment. Okay, then what will happen? Here is sun, in middle there is earth, in right hand side there is moon. This is known as full moon day, that is Purnima. So due to the attraction of moon, there will be swelling of water in direct part and the far side there will be the high tide and there will be receding of water on that 90-degree position and there will be too low tide. After that moon will reach in that position. So what will happen? This is the alignment of 90-degree. Here the attraction force of moon and the attraction forces of pulling forces of sun will be segmented. There will be division. So there will be high tide in that zone and that zone and low tide in those zone. There will be also high tide, that is known as Neap tide zone, and 180-degree alignment is known as spring tide zone. So Neap tide is the sun, moon, earth aligned in 90-degree angle. Okay, here there is also too high tide and too low tide, but this is not so powerful tide like 180-degree alignment like the spring tide. And in spring tide, alignment of sun, moon, earth is 180-degree. So Neap tide and spring tide, two types of tides, basically within the 27 days and 24 hours. I mean 27 and half days. This is a monthly phenomena. Okay, spring tide and Neap tide. After full moon days, after 7 days, they will attain Neap tide. After the new moon day and after the 7 days of new moon day, the earth will attain the Neap tide. Okay, in Bengali they are in Ashtami Tithi. Now come to the another type of spring. So it is clear that the full moon day and new moon day there will be the spring tide, and the 8th day after the new moon day and full moon day there will be the two Neap tide zone. So now come to the another type of tides, that is diurnal range, diurnal tide, semi-diurnal tide and mixed tide. It's related to solar day or lunar day. So solar day and lunar day. So we can also take the help of this paper. This is suppose this is 360-degree. Suppose earth is 360-degree and revolving in 24 hours. If there is one high tide, this is a high tide and it low tide within a solar day or lunar day, 24 hours and 15 minutes, that is known as diurnal tides. It's normally occurred in the coastal zone of Mexico, Alaska. This is basically occurred due to the interference of the continent. Now the semi-diurnal means semi means divided, total divided by 2. So one lunar day is 24 hours and 50 minutes. So semi-diurnal means 24 hours and 25 minutes. Two high tides, this is 360 and this is 24 hours too. So two high tides and two low tides are known as, if occurs, it's known as a semi-diurnal. It's the range differences of time is total lunar day divided by 2, 24 hours, 25 minutes. Okay. Now come to the, so it's clear that it's related to the lunar day or solar day. It's related to the sidereal month or months, or within the 27 days. Those are the types of tides. Now come to the another aspect of tides, that is the relevant of tides of, suppose this is our earth, this is earth, okay, and you know earth shape of the earth is perfectly sphere, so the equator length of the equator is greater than the pole, so gravitational forces of the earth is higher in pole and lesser in equator. So the tidal effect or tidal range is less or lower in pole because due to the gravity, and comparatively higher in equator due to shape of the earth equator. But tidal activity is more prominent and dominant in the mid latitude within the 24-25 to north south to 40 north south. Okay, but it's lesser in pole due to the higher gravity of the earth, and higher in compared to pole, higher in equator due to the gravitational attraction of the earth. Okay, and it is very important and plays dominant role, and magnitude is very high in the mid latitude. Now come to the significance of tides. Why the tides is so important and so plays a very vital role for the coastline and coastal topography. The tides is very important. Normally rivers come from the higher elevation to lower elevation. Suppose this is the ocean body, and in estuary region meet the ocean. In the high tide zone, the level of water vertically increased, and that's why river cannot flow from higher elevation to lower elevation. Then rivers, this is the basic principle, higher elevation to lower elevation. The estuary zone, due to high tides, during the high tides, there will be a reversal situation. The situation will reverse, and the ocean water push the river water to the inland. This reversal situation is known as borehole. If this reversal situation is known as tidal bore. Okay, when the river is flowing to the inland in the estuary region, due to this elevation not following the surface elevation. Okay, this is known as tidal bore. Okay, tides is very relevant because tides plays a very important role in coastal ecology and beach ecology and beach formation. Okay, suppose this is the continent and this is the ocean water. When this is the maximum range of high tide zone, this is the maximum range of low tide zone. This range between the high tide and low tide known as foreshore, and next part is known as near shore, and last part is known as offshore. So This is the zone of high tide to low tide, is also known as the littoral zone, and is also the zone of longshore current. So, longshore current formation, littoral zone, this deposition and the erosion of that zone, basically the shore ecology, the beach ecology is directly related to the tides. In Sundarban area of West Bengal are basically the longshore zone, and the littoral zone is adversely affected by cyclone and super cyclone due to the high tides and stormy conditions. Okay, those are the basically a basic effect of the tides, and tides is very relevant in the coastal ecology, estuarine ecology, and riverine ecology in the coast region. And basically, and last and very important thing about the tides is that the moon's gravity is greater than the earth gravity, then water is moving in the front side of moon, and first side of moon is swelling due to the centrifugal forces is greater than the moon gravity. This is the basic principle behind the tides. Okay, thank you very much.